Solve each equation or inequality. So, our first problem is a quadratic equation. In order to solve a quadratic equation, we first want to get one side equal to 0. So in order to do that, I'm going to subtract 2 from both sides, which would give us x squared minus 6x plus 8 equals 0. Now, I'm going to see if I can factor this. Now, these two terms obviously have to be x. These two terms have to multiply to give us 8. We should also notice that since this 6 is negative and this 8 is positive, that these two signs must be negative, because a negative times a negative will give us a positive, but the outside and inside terms will combine to give you a negative. So I'm going to try 4 and 2. You will notice that the minus 2x from the outside and the minus 4x from the inside will combine to give you negative 6x here in the middle. So, now that we have this factored, that means either x minus 4 equals 0, or x minus 2 equals 0, which means x equals 4 or x equals 2. Now, 2b is a quadratic inequality, and you can see that it corresponds to the quadratic equation that we solved in part A. Now, I'm going to take this inequality and I'm first going to subtract the 2 from both sides. Recall that when solving inequalities, if you add or subtract from both sides of the inequality, you don't have to change the direction of the inequality. Now I'm going to use what we figured out in part A to help us solve this inequality. And I'm going to consider what the graph of y equals x squared minus 6x plus 8 looks like. That would be a parabola, and based on what we figured out in part A, we know that its x-intercepts would be 2 and 4. Because when x equals 4, the y equals 0. So 2, 0, and 4, 0 would be 2 points on this parabola. And since the coefficient of x squared is positive, that means the parabola would open up. Now, I'm going to use this graph to solve this inequality. Now, what we're trying to look for is where this expression here is greater than or equal to 0. Which means we're trying to find the values of x on this graph where the y's are greater than or equal to 0. If we want y to be greater than or equal to 0, that would be this part of the graph. And let's consider what x's go with those y's. Well, when x is 4, or anything to the right of 4. Or when x equals 2, or anything to the left of 2. So these are our solutions to this inequality. So I'm going to use this graph to figure out how to write a compound inequality. And we need a compound inequality to represent these two regions put together. So first of all, this region, the numbers to the right of 4 would be x is greater than or equal to 4. And these numbers to the left of 2 would be x is less than or equal to 2. And our values of x have to be one or the other, but not both. So we need to combine these two inequalities with the word or, because any value of x that is either greater than or equal to 4 or less than or equal to 2 will solve this inequality. And this inequality is equivalent to the inequality we want to solve. So these will be our solutions to our inequality. Now, take a moment, pause the video, and see if you can do part C on your own. Okay, I hope you've tried the problem now. First thing I'm going to do is to get one side of the inequality to equal 0. So I'm going to subtract 2 from both sides. Now, the next thing I'm going to do is I'm going to get rid of this negative 2 here, or that is to say, I'm going to get rid of the negative. In a little bit, I'm going to try to solve the corresponding equation. But to solve the equation, it's very difficult to factor with this negative. So I'm going to multiply both sides by negative 1. I'll even add that in here, what I'm doing here. I'm multiplying both sides by negative 1. And when I do that, I'm going to have to change the direction of the inequality. Now, negative 1 times 0 is still 0, but on the left side we're going to get positive 2x squared minus 3x minus 5. And now I'm going to consider the corresponding equation. 2x squared minus 3x minus 5 equals 0. And let's see if we can factor that. We would need a 2x and an x, and this would have to be 1, this would have to be 5, this would have to be negative, and this would have to be a positive. So that we would get a positive 2x from the outside, a minus 5x from the inside, which would combine to give you minus 3x. So now, either 2x minus 5 equals 0, or x plus 1 equals 0. So, this is a two-step equation. I will add 5 to both sides, and then divide both sides by 2. This is just a one-step equation, so I just need to subtract 1, and I get x equals negative 1. Now, what we're trying to do is to solve this inequality here, which is equivalent to the one that we started with. And again, what I'm going to do is I'm going to use a graph to try to help us figure this out. Let's consider the graph of y equals 2x squared minus 3x minus 5. That parabola would have x-intercepts at 5/2 and negative 1. And this 2 is positive, which means the parabola would open up. And again, this time we want to figure out where the outputs of this parabola are greater than 2. Greater than, but not equal to. Once again, that's going to be here and here, which means we want the x's that are to the right of 5/2 or to the left of negative 1. So, our final solution is x is greater than 5/2 or less than negative 1. Okay, let's try one more. Go ahead and pause the video and try D. Okay, so again, the first thing I will do is, unlike the last problems, where I would get one side equal to 0, in this case, since there's no term with just an x in it, I'm actually going to add 1 to both sides and just try to isolate the x squared. Now I will now I'm going to add 1 to both sides, which would be 30. I'm sorry, scratch that. I'm going to divide both sides by 3, which is going to make this 29 thirds. And now let's consider the graph of y equals x squared and y equals 29 thirds. Y equals x squared looks like this. And y equals 29 thirds is, of course, a horizontal line, which looks like this. Now, these 2 points of intersection would be the square root of 29 thirds, comma, 29 thirds, and negative square root of 29 thirds, comma, 29 thirds. And if we want to figure out where the x squared is less than or equal to the 29 thirds, that would be here in between. So the x's that go with this would be from negative square root of 29 thirds to the positive square root of 29 thirds. All of these points in between. And therefore, x would be less than or equal to the square root of 29 thirds, and x also has to be greater than, and these should be or equal to the square root of 29 thirds. And we need to combine these two inequalities with the word and, because the x's have to satisfy both of these inequalities to be between these two numbers. If you wish, you could also write your solution like this. And this, oh, I'm sorry, this should be negative. So, just to summarize what we've done, if you have a quadratic inequality, you first of all want to figure out how you can solve the corresponding equation. Once you have the corresponding equation, see if you can use the graph in order to figure out what values of x make the expression either greater than or less than whatever constant you're dealing with.